My name is Maciej Winnicki, and I am senior UI developer at Ignite. And today I will talk about the single-threaded event loop in JavaScript. In general, how it works, and how it works in mainly Node.js, maybe a bit how it works in browser, but generally how the concept looks from the overview. So this presentation is a result of my research, mainly on GitHub, mainly on Google groups, and I was reading a lot of this posts because it's not the easy thing to understand how all those things works. So, but we will start from the server side, from the node. So, let's say that we are trying to make a web server that handles. There should be animation, but there is no. Okay. So we are doing the web server that should accept simultaneous requests. And we can do it in a few ways in terms of concurrency. We can do a synchronous server that handles only one connection at a time, handle it and move it to another. We can use processes like it's in Apache server, but it's a lot of memory, so it's not the best way to do it. We can use threads, but there are some issues with thread safety and so on, and Apache also can do that in some configuration. And we can do an event loop, and this is how it's done in Nginx, the web server, quite popular, and of course in Node. But why is it good to use event loop in terms of web server? Because there are a few things that is important. First of all, there is no race condition because there is only one thread, single thread. There is no shared memory, so we don't need to deal with all those stuff related to the switching between processes accessing the same region of memory. And it's good for IO-bound tasks like switching. This is what web apps do. So we are switching between sending requests, between reading file, querying database, and so on. But it's not the best way to do it if we should do a lot of CPU intensive tasks like calculating something or something like that, because like I said, there's only one thread, and if we block it, nothing else will be done. In general, we can say that there is a need to handle a lot of events. In terms of web server, it's request. In terms of browser, it's user interaction. And those events are in the same time. We can say that it's not the same time, but are simultaneous. So let's look how it works in Chrome, in a browser in general. So in a browser, we have because the concept of the event loop came to the node from the browser world. So I will talk about the browser for a moment. So in general, there is a UI thread in browser that handles all the painting the page, all the interaction between user and the browser. And in that thread, we have, in terms of Chrome, it's V8, and we have event loop, and of course there is a callback queue. I will go into details about all those elements later. And there is web APIs. This is all the window object or the web window timers, Ajax. It's all there. It's not in a JavaScript. The V8, it's only the implementation of the JavaScript. It's only implementation of the ECMAScripts. Nothing more there. Okay. So in terms of Node, it looks quite similar, but there is no web APIs, there is Node API. So all the HTTP server and so on, it's all in the Node APIs. And what is important, quite important here, that Node APIs are handled by the thread pool. In current version of Node, there are 4 threads in this thread pool, and I suppose it was the same number from the beginning. Yeah. So in general, we can say that this approach with event loop is good for the front end and back end. But let's look closer to the V8. V8 has a heap and a stack. Heap is a memory region where all the objects are allocated. So all the functions, all the data are there. And there is a stack. Stack is a data structure that holds all the information about currently run code that the JavaScript engine is currently running. It's a stack, so we can put on the top of it and push on the top of it and pop from the top of it. So it's a LIFO, last in, first out data structure. So let's look how it works in JavaScript. So we have two functions and one function call. And on the right, there's a call stack. So we are running this code. This function is only declaration, so we are running this one. We are adding to the call stack, and we are running this. But inside this function, there is another function call. So we are adding to the call stack. And we are summing those two numbers. We know that it's 3. We are assigning to the variable. So the add is done. We have console also there. So we are running the console, and we are done with this function log sum. So that's all. So this is how it looks in browser. This is the call stack. It's exactly the same what I just described. But this was the easy example. Now there was no asynchronous operation. There is only synchronous code. So let's look how it works when there is some asynchronous. But to understand how it works when there's asynchronous calls, we need to provide an event loop and a callback queue. So there is the event loop, this one on the bottom, and there is callback queue. So we have almost the same code, but the console log is wrapped with set timeout call. So we are running the same. We are adding to the stack, we are summing, assigning to variable, and now we are calling the set timeout function. The set timeout is not in the core of JavaScript. Like I said, it's the external API. In browser, it's web API, Windows timer, and in Node.js, it's also timers. So we are calling this, but it's handled by the Node API. There's a set timeout with delay 10. So the 10 seconds after, we have nothing in call stack because everything finished, but still there's a callback function, this function with console log, in the Node API. So the loop is starting to iterate, and the first step, it checks the timer. If its timer is exceeded, so it's adding to the callback queue, it's iterating more, it's adding to the call stack, and then we are executing this function. So it's console log like before, and we are done. But again, this was quite easy example, because in normal real application, there is much more asynchronous operations like calling database, sending requests, and so on and so on. So there is, there is a lot of that stuff, and I must say there is no single message queue, but there is some different message queues. But general, the overview, I hope that you get that there is the callback queue that the event loop gets the functions from there. So how does it look exactly in Node.js? So when the event loop is starting to iterate, the first thing it's do it update the timers. So if we have a lot of set timeout or set interval functions, the first step is that it checks if any of those timers should be run in this iteration. If yes, it's run the set timeout and set interval functions. Then there are I/O callbacks. So all the database queries, all the file API queries, all the requests sending to external services are done in this moment. All the callbacks from these operations. So at this moment, Node ask the operating system to get all the events that happened on the file descriptors, but this beside. And then there is some interesting function, all the callbacks from the function that's set immediate. I will talk a bit about it later. So we have timers, and we know what is it because it's also in browser. And we know what is the difference between set interval and set timeout. But they are not accurate. I probably all of you knows that if we say that we want to set timeout 10 with 10 milliseconds, it will not be executed after 10 milliseconds. It can be, but it's not. We can't be sure that it will be executed after 10 milliseconds. And this is because of the timer's resolution in a browser. For example, in Chrome it's 4 milliseconds. So if we creating a set timeout with 1, 2, 3, or 4 milliseconds delay, it will be executed in the same time. It's no difference. But we can be sure that the order is preserved. That if we create a few set timeouts with 0 delay, it will be executed in the order that was declared. Yeah. So this is what I said. The callback 1 will be always before callback 2. And there's this function set immediate. This function is only in IE10 and in Node. And this function is much more interesting than the timers. And also the order is preserved when we declare the callback to this function. And there is only one call of this function per loop iteration. So if we add the 10 set immediates, only per loop iteration there will be only one callback called. And this function is much more accurate than set timeout because there is no timer. The timers are not involved, so there is no this timer's resolution and so on. So in general, we can say that set immediate will be before set timeout with 0 because, as we said, the set timeout is at the set immediate is at the end of the event loop, and timers are at the beginning. But this is not completely the truth, because if you run this code in a node, sometimes the set timeout will be faster. But this is not deterministic. It's you can say the bug in a node. But this depends on a few things internally in Node, and one thing that is the most important, that if it's the first ever loop iteration, and there can be some things that are not deterministic. But we can be sure that set immediate is always after IO events callbacks, and is always before timers, like I said. And in general, this function is used to break up long-running operation. This is why it is introduced to the node and to the IE10. You know, there's in Chrome and Firefox there is request animation frame. So this is why probably they are not introducing this function. And there's the last function that can affect the order of the operation in event queue. Event loop, sorry, and this is process next tick, and this is function only in Node, in the process API, and in general, this is very complicated function. There's a lot of misleading information in the groups, in the GitHub, how it works, but I don't know for sure that it works how I will explain to you, but I hope that it is. This is true. For sure, it's true for the last version of Node, 0.12, the master version on GitHub. So this runs after all currently running synchronous operations, but before any other I/O events fire. So we can say in general that we have an event loop, we have update timers, we have set timers callbacks, and now process next ticks callbacks are run from those callbacks from timers, and we are moving. And also at this moment, the process next ticks functions are run, and this is similar to the set immediate, and also at the end of the set immediate, the process next tick callbacks are run. So, but what is it important in this function that we are using, or why is it important to be in the Node API? So this is important in developing APIs where we want to give a user a chance to assign event handlers after an object creation, but before any I/O. So we want to assign the, like I said, event handler before I/O. So we want to listen, for example, some reading file, but we must do it before there is I/O in the event loop. And there is another quite important thing why this function is important, that we should always make a function that are 100% synchronous or 100% asynchronous, because it can create a lot of mess in the code if there would be no process next to it, because in some cases this would be a synchronous function. So this is why the process next to it is important. So to wrap up all the information that we get, I try to explain what will be the effect of this function. So we are running set timeout. So we are assigning the timer callback. The event loop is finished, and there is another. Oh no, it's not finished. So yeah, so we are the event loop is finished, and we are running the callback from this set timeout. So we are running set immediate, and then we are running set timeout. So we are added two callbacks, one to set immediate and one to the timer. So we are running the loop, and this is what we will be called first, because the set immediate is at the end of the current loop. So we are calling the console log. Then we are calling the console log from inside the next tick. And then we are calling the console log from the timeout. And then we are calling the console log from the next tick inside the timer. But there is one important thing with this function, that this function, if we add the next ticks inside next tick and inside next tick, it can block the event loop, because it's not like set immediate that there is only one call per iteration. There can be recursive iteration that block the event loop, and this is why there is a parameter called max tick depth that says how many this nested next tick calling callbacks can be one per one loop iteration, and its default value is 1000. So yeah, to get again, this is quite important. So I will say it again: update timers, I/O callbacks, and set immediate, and that's all. Thank you very much.
Okay. Yeah, we'll have some time for the questions. Before you rush out to get your food, I remind you that there is a round of lunch stated here. So there are two rounds of lunch. First is at 2 p.m., second is 2:45. And check which round is yours. Just make sure you go to the right round so that it's not too crowded on any of those. And there's still time for questions, so I give this mic back.
Hi. So you said that set immediate functions will be always invoked before set timeout. Yet on your graph, the process was like reversed. You first checked timers, then you invoked all set timeouts callback, which is supposed to be invoked after set immediate, and then you proceeded to set immediate. So like the queue was reversed.
I will turn it off again to show you what I mean. And this is because the set, I mean that if we have a set immediate in a callback from the set timeout, it will be run at the end of the event loop. So the set immediate from this code will be always before the timer. So if we have the set immediate and set timeout with 0, the event loop is going, and it's set timeout step in a set immediate step in an event loop, and after that there are timers at the beginning of the event loop.
Okay, so one issue I have is with the very beginning of the presentation, because you said we can use threads or processes, and the only other alternative is to use event loop, which is not true, because we could use lightweight threads of any kind, like GHC lightweight threads are much faster than the Node's event loop.
Yes, of course. This was the most popular things how the web servers are created right now. So this
just wanted to point out.
Hi, thanks for the presentation. I seem to recall there was a discussion in Node community about removing max tick depth in 0.12. Do you know how that was resolved in the end?
I don't have information about it.
That's it, thanks.
Okay, thanks.
Thank you.